When you take a shower or flush the toilet, what happens to the water? Water and waste wash down the drain of homes, businesses, and industrial facilities flows through a network of pipes called a collection system. According to the U.S. EPA, there are about 800,000 miles of collection systems in the U.S., along with 500,000 miles of private laterals which connect properties to the sewer system. Water typically travels through pipes by gravity. Once pipes get too deep, a pump or lift station moves wastewater into a new section, and water moves downhill again. Many older cities have combined sewers that convey both stormwater and sewage. A large storm can overflow the sewer and greatly increase the volume of water reaching the plant. Wastewater travels to the 16,000 publicly owned water resource recovery facilities, commonly called wastewater treatment plants, that serve over 190 million U.S. residents. The first part of the treatment process is called the headworks. Influent screens filter out large debris like rags, cans, and other trash, represented by the yellow spheres. The removal of large debris helps keep pumps and pipes within the plant from getting clogged. The trash removed from the screens is collected and disposed of at a landfill. The goal of the headworks is to remove inorganic matter from the wastewater. Inorganic matter includes items like trash, sand, or gravel, basically material that did not come from a living creature. The next stop within the headworks is the grit removal chamber. Grit is made up of large, heavy particles like sand or eroded cement. Water flows slowly through this tank, keeping organic matter like food, waste, bacteria, or excrement in suspension, but giving the heavier grit a chance to fall to the bottom. As grit settles out, a rake runs along the bottom of the tank, sweeping the grit away. Removing grit early on is important because it is abrasive and can erode mechanical equipment. It can also build up in later treatment processes. Though not shown here, flow monitoring occurring in the headworks helps operators prepare for volume and velocity of water entering the plant. Based on this information, operators can add the proper amount of treatment chemicals and allow adequate time in each treatment process. Flow monitoring happens throughout the rest of the plant. After the grit removal chamber, wastewater flows into primary treatment. The first step is a set of fine screens that can remove even smaller debris. Again, the debris is collected and taken to the landfill. The main goal of primary treatment is to separate water from solids, known as organic matter. This differs from the headworks, which is designed to remove inorganic waste like trash and grit. Like the headworks, primary treatment relies on physical separation methods, such as screening and sedimentation, which causes sediments to settle out by gravity. Primary clarification is the next step in the treatment process. Wastewater comes up through the center of the clarifier. Water typically sits in the clarifier for 1 to 2 hours and becomes quite still. 90 to 95% of settleable solids fall to the bottom over time and are removed. 50 to 65% of suspended solids are removed. These are very small organic particles that float in the water column. Oil and grease floats to the top and is skimmed off. Cleaner water flows over the clarifier weirs as solids settle out. A rotating arm breaks the solids from the bottom of the clarifier into a hopper in the center. The solids skimmed off the bottom of the clarifier travel to the biosolids treatment process. The water now